The latitude 50 degrees as a result of the Earth rotation about its axis. Angle to the true vertical with the mass hanging out. Oh, so you have to find the radius for 50 degrees.
Yeah.
So this is the Earth. Down. So that's the Earth.
Yeah.
And then 50 degrees.
Okay.
So this angle is 50 degrees.
Yeah.
And then we have to find the radius, because that's the axis for the rotation.
Yeah.
And that's 50 degrees, so this angle should be 40 degrees.
Yeah.
Yep. So do you know the radius of the Earth?
I think it says it in a different problem.
Okay.
Like,
All right, now.
yeah, I don't think we have it.
Acceleration equals omega squared r. So omega is the angular speed.
Yeah.
Have you learned that?
Yeah.
Yep. Okay. So can you figure out the angular speed here?
Yeah, but we don't have the radius.
Yeah, we can figure out the angular speed, and then we need a radius here. So the radius here is not, this r is not the radius for the Earth, right? Should be here, all right? If I use the capital R to represent the radius of the Earth, then r should equal r sine 40 degrees, right?
Yeah.
Okay. So how can we find omega? We find omega first.
Let me check the formula.
So omega is easy to find. Remember, so the period for the Earth the period for the Earth for his own rotation is 1 day, right? So 24 hours. So 24 hours for 360 degrees. But we have, I think, for angular speed we have to use the reading, right? So we have to use 2 pi.
Yeah.
So 2 pi over 24 hours, but we have to convert to seconds. So it's 24 times 60 times 60 again.
Yeah.
Right?
The angle swept out in that time.
Yeah. So that's the angular speed for the Earth at latitude 50 degrees.
Yeah.
You can.
So it's constant throughout the day.
Sorry?
The angle speed. It's constant.
Yeah, it's constant, of course. It's constant.
Yeah.
If not constant, you will feel dizzy.
Yeah.
Okay. So, but the point is, we still have to know the radius of the Earth.
Yeah.
I think we can Google it. Let's just Google it.
Yeah.
Okay, so the radius of the Earth is r equals 6.3781 times 10 to the power 6 meters.
Yeah.
Yep. Now you can easily find that the lowercase r equals that number times 4 sine 40 degrees. Can you calculate now?
Yep. So we're just doing the acceleration now?
Yeah. We have to find the lowercase r first, which equals capital R times sine 40 degrees.
Yeah, so what is the lowercase r?
A lowercase r is here.
Yeah, but what does it represent on the thing?
Means that the radius for the rotating circle in 50 degrees latitude. Because,
like, why do we have 2 radiuses?
Because the Earth are rotated around this axis, right?
Yeah.
So, and at this plane, the Earth for the rotation for the Earth actually is a circle, right?
Yeah.
And the radius for the circle is the lowercase r.
Alright. Yeah, it still doesn't really make much sense to me.
Yeah. Then you just substitute the number here.
Yeah. Okay, so trying to find the acceleration stuff.
Yeah. So the lowercase r equals 6.3781 times 10 to the power 6 times sine 40 degrees.
Okay.
And you can find it by your calculator.
4 times. It was squaring the angular velocity. Times by 6.3781 times by 10
to the power 6.
6 times by sine of 40.
Yep. So when you square the omega, remember you must use bracket to include everything for that one.
Yeah.
Yep.
Okay, so I go like 3.64 times by 10 to the 13.
3 what?
64.
64 times 10 to the power.
By 10. Yeah.
10 to the power what?
13.
13. I don't think it should be 13, because the power, because the radius here is 10 to the power 6. Should be lower.
Yeah.
The power should be lower than 10 to the power 6, because omega is quite a small number.
Yeah. Okay, I'll try it again. So 2 pi divided by 624. Oh, no, I need brackets for that. Yeah. I think I know where I made a mistake.
Yeah, you need a bracket for 24 times 60 times 60.
Yeah, that's where I made a mistake.
Yep.
Okay, and then times by 6.63781 times by 10 to the 6. So I got a really low number this time.
Yeah, should be a really low number. Yeah.
0.351
meter per second
squared.
Yeah, that should be a very low number. If it's a very huge number, you should have the feeling. But now you don't have any feeling in that.
Alright. The way to record this is I want to look back on it later.
Oh, I can record for you. I can send you.
Okay.
I'm recording now.
Okay.
If you have a tablet version, especially for the Android version, you can record it. But for computer version, I don't think you can record it.
Yeah.
Alright.
Alright.
Okay,
I'm
next.
just working through all of these.
Yep. So next question, the second question.
Yeah, 12. Oh wait, are we done with 11?
I don't think so.
Yeah, we're not.
Okay, so express the answer as acceleration with g. So that's a here. You should use a divided by g. That's a fraction, a on g, right?
Yep. Okay, so this is 0.351 divided by 9.8.
Yeah.
Okay. So do we put that in? Okay. That's like 0.0358.
G.
Yeah.
So just roughly less than 4% of G. So it's very tiny for the centripetal acceleration. Yeah.
Okay, so what angle to the true vertical would a mass hanging at the end of the string make? End of the string make.
Okay. So the true what angle to the true vertical with the mass hanging at end of string? Okay. Now, so the gravitation and G should point to the center of the Earth, right?
Yeah.
So I'll show you the diagram here. I'll start a new page.
Yeah. I restart a new page.
I can start a new page for you.
Okay.
Yeah.
Alright.
Okay, so
Is this on the Earth or is this talking about the Earth?
on the Earth thing.
Ah.
Yeah. So that's 40 degrees. And then, so that's the direction for G. G in that direction,
Yeah.
right? So I is in that direction.
Yeah.
Yep. So the original diagram should be I here.
Right, so
Here.
actually, no. Why is the acceleration in that direction?
Oh, because the acceleration is always point to the center of the circle. You rotate to the axis, right? So in that surface should be a circle, and I should point to the center.
Yeah.
Yeah.
But isn't G pointing to center? What about the A?
A is the acceleration we got, is the centripetal acceleration, and G
Doesn't.
is always point to the center of the Earth.
Yeah.
Yeah.
So why doesn't the centrifugal acceleration point toward the center?
Oh, because the centripetal force is always pointing to the center, right? Like
Yeah.
the centripetal force is always to the center.
Yeah.
So that's
So is the force from the acceleration?
yeah, because force equals m times acceleration. They should have same direction.
Yeah.
Yeah. So that angle here should be 50 degrees,
Yeah.
right?
So is that yeah.
So if there were no A here, then the strain should directly due to the center of the Earth. So the strain should be here. If there's no A here, right?
Yeah.
Because the strain, anything you hang in the air should point to the center of the Earth if there's no centripetal force, so due to gravitation, right?
Yeah.
But there's a tiny centripetal acceleration, so the strain might have a very tiny deviation to the center of the Earth. So we have to find the angle here, this angle.
Right.
Yeah.
Okay.
Now we use the parallelogram to find it. So I here,
Yeah.
G here, 50. So we have to find this one. That's the net acceleration, right? The diagonal is net acceleration.
Yeah. Yeah.
So if that's 50, this angle must be 130, right? Because parallelogram
Yep.
is 130, and I redraw the triangle here. That's G, that's A, that's 130,
Yeah.
and you're trying to find this angle, right?
Yeah.
Okay. I think you have to use cosine rule.
Yeah. So, b squared.
To find this side. To find this side first. Yep.
So we got two sides and an included angle. So.
Yep.
Cosine of A. I just quickly search up the cosine rule to make sure I wrote it down correctly.
Okay. So cosine rule is we're trying to find x. Be x squared equals g squared plus a squared minus 2ag cos 130 degrees here.
Yeah, okay. Yeah, I got it. So that's g squared plus a squared minus 2
ag
or ga.
Yeah, ag 130.
Yeah, ag 130.
Yeah.
Is that 131 or 130?
130 degrees because the angle is 130 degrees.
Okay. And then, so how do we find a though?
Oh, you got a.
Is that from the other? Yes, we already got it.
Yeah.
Okay, so that's 9.5 squared. What was that value for a?
You got the value for a here.
Oh, I didn't write it down.
Okay, sure, no worries. This one.
Plus 0.358 squared. Oh, no, we want the first one, yeah.
Yeah, if you sub g by 9.8, you need the first one.
Yeah. That's 2 times by 0.351 times by 9.8. Cosine of 130. Wait, hang on.
Oh, hang on, just double check. 2 times.
That's 9.8. Sounds like cosine. 130. Just made a mistake. I'm just trying again.
Yep.
Times by 0.351. We sign the one. And take the square root of that.
Yeah.
So I got 10.303. Yeah.
Oh, hang on, just 1 minute. I think you got the wrong answer for the question 1. Yeah.
So the first one?
Yeah. For the acceleration, I just recalculated because I saw the answer for question 11 is 0.02169. So I just double checked, and I found I got the answer as the same as the answer here, but you didn't get it.
Yeah.
Yes. So.
All right.
So actually, A doesn't equal that.
Yeah.
You just I think my method is right because I can get the answer. You just recorded the number here, which is 0.02169. What I got is 0.02166, just because the middle approximation doesn't matter. It should be right. So I just rewrite the answer.
Right.
Yeah. I is not here.
So
Yep.
was it just the calculation I was on? Or?
The first question, acceleration.
Yeah.
The answer should be 0.02169.
Okay. So what was the mistake that was made?
I don't know, but I just input my number in your calculator. But I will show you here. So I should show you step by step. So omega equals, I'll just write here. You see the expression for omega equals over 2 pi, equals 2 pi over that? I'll just show you in my calculator. So 2 times pi divided by 60 divided by 60 again, divided by 24. Alright, so this number is 7.2722 times 10 to the power negative 5 rad per second. So that's the omega. And we find the lowercase r. So the lowercase r here equals 6.3781 times a million, which is 10 to the power 6.
Yep.
Then times sine 40. Sorry,
Yep.
sorry, it's sine 40 first. Sine 40 times 6.3781. So this number equals 4.09 or 4.10. Sorry, it's 4.10 times 10 to the power 6 meters.
Yeah.
All right. Then A equals omega squared times r here. So I just use 7.2722 times 10 to the negative 5 squared.
Yep.
So omega squared equals 5.2829 times 10 to the power negative 9. Then times r, which is 4.1 times 10 to the power 6. 5.29 times 4.1. Yep. So that equals 2.169. 0.169.
Yeah.
10 to the power negative 2.
Yes.
Meter per second square. That's the answer.
Yeah.
You have something wrong when you calculate that.
Yeah. I think I just forgot to put sine in.
Oh, okay.
I think that's the mistake I made.
Okay. Okay. So then you have to recalculate the angle.
Yeah. Okay. Yeah.
Yeah.
So equals square root of 9.8 squared plus 0. What was it?
0.02196.
2196 squared.
Yep.
Minus 2 times by 9.8 times 0.02196. 2 times 130 squared. Okay, I got like 9.81.
9.81? Okay. So x equals 9.81. So you find the theta, you have to use sine rule again. Use sine rule.
Yeah. So, yeah.
That means a over sine theta should equal x 9.81 over sine 130 degrees.
Yeah.
And so sine theta equals a sine 130 degrees over 9.81. When you find this value, is sine minus 1, you find theta.
Yeah. 9.81. So theta equals sine inverse.
Yeah, theta equals sine minus 1. A, you just substitute the value A, so A sine 130 over 9.81.
So 0.021. But are we using 9.81 or?
Use 9.81 because we need x. X is 9.81.
Yeah. So 0.021 sine 130.
0.02169 times sine 130. Yeah.
Okay, 2169. Times sine 130. 69. Sine 130. Divided by. Hang on. 0.02769. Yeah, I got 0.097.
Yeah, that's the answer. That's the answer.
Yeah, okay.
Yeah, it should be small. If it's larger, you will see that. For example, it's 10 degrees, you won't see it's perpendicular.
Yeah.
So that's a very tiny angle. Yep, we got the answer.
Makes sense. It wouldn't deviate too much.
Yeah, that's right. Because the Earth doesn't rotate very fast. If it did, then we will feel dizzy.
Yeah.
Yeah.
Alright.
Yep. Like when you play on the merry-go-round, if they become faster, you feel dizzy. Cause, yeah. Alright.
Yeah.
Next. New page. 12. Horizontal disk has a whole February center string. Oh, where's the diagram? Oh, diagram for 12. Okay, that one. Speed m be such that thickness stands still. Okay, so that means the centripetal force should equal the gravitation of m, right?
Gravitation of M?
Yeah, I will show you that. I will redraw the diagram for you.
Yeah.
Okay, so the capital M stands still. That means the tension of the string must equal the gravitation, which is mg here, right?
Yeah.
So there's tension here, and the equation is T equals capital Mg, right? And the same thing, because the same string, they should have the same tension. So tension here should be the same value.
Yep.
Right? So actually, the capital mg should be the same value of the centripetal force of for the lowercase m, right?
Yeah.
Okay, so then the centripetal force for lowercase m is mv squared over r, right? That should equal
E is equal to that.
mg,
Oh yeah.
right? Okay, they what the speed? We just make v the subject. So v squared equals lowercase r capital M g over lowercase m, right?
Yeah.
The times r then divided by m. So v equals square root r m g over lowercase m. That should be the answer.
Yeah, and we don't have values, so we can't solve it.
We don't have value. They just like express it by the polynomial.
Yeah.
Yeah, and that's the answer. I saw the answer. That's right. Yeah. That's 12.
Yeah, okay.
Okay. Next question, 13.
This one we did in class, so I don't think I need to do this one.
Okay, so move to 14.
Yeah.
Let's move clockwise around the vertical circle. Figure 8.18. Do you have the figure for 8.18? The figure is not shown here.
Yeah. I don't have the figure.
Oh, then we have figure out the figure. Okay. But I think we do know we have to know the position of A and B. We have to know the diagram. Otherwise, we don't know where is A and B.
Yeah. It says 45 degrees to horizontal.
But 45 degrees horizontal could be like this. That's the vertical circle. So 45 degrees, does that will show you that's the horizontal. It could be like this. Could be like this.
Yeah.
Or like this. Or like this.
Yeah.
So which one? Which one is A? Which one is B?
I think it's top ones, because if it was the bottom ones, it would have been like negative 45 degrees, would be going the other way.
Okay. Then A should be okay. A should be here. I think B should be here.
Yeah.
Because they say at A the speed of mass is increasing.
Oh, it should be increasing on the way down the circle.
Oh, sorry, I just read
So
all.
which way is
Sorry, I
clockwise?
just read all.
So
Yep, yep. Makes sense.
It's clockwise.
Yeah, clockwise. If it's clockwise, I should be at the right, I think. What do you think?
Yeah. So it's anti-clockwise, though. I'm pretty sure. So.
Is it clockwise or anti-clockwise? Oh, anti-clockwise. Okay. All right. If anti-clockwise, that should be A. That should be B. Just go that way.
Yeah.
Because when you reach B, the speed will becomes lower and lower because it's climbing up.
Yeah.
Right. Okay. So A should be there.
Yeah.
Yep, and that's 45 degrees. 45 degrees. Okay. A radius is 4 meter. Oops. Yep, 4 meter.
So you got to combine the tangential and centrifugal accelerations, right?
Yeah. Yep. Angle. Wait a second. Okay, so that means at position A and B, they should have the same speed, 4 meters per second, right?
Yeah.
Yep. B is decreasing acceleration as each position gets. Okay. So now we'll do position A first.
Yep.
Okay. Now we redraw the diagram. So we have a centripetal acceleration here, A, and then we have a perpendicular acceleration in I think is which direction? Yeah, the tangential acceleration.
Yeah.
This way.
Yeah.
A1 here, A2 here, and the net acceleration at A is 3 meters.
Yeah.
Should be in that way.
Yep.
Speed. Okay. Okay. So A1 here, they have a speed 4. So A1 here is A1 equals V squared over R, right?
Yep.
So it's 4 squared over 4, because the radius is still 4. That equals 4.
Yeah.
So A1 equals 4. And then we know the net acceleration here, which is 3 meters per second squared. So it's 3 here.
Yep.
That's 4.
Yep.
Oh,
Wait, shouldn't that be A2?
that's A2 is 3. Yeah, that's right.
Yeah.
Yeah. And the question is the magnitude direction of the acceleration vector. We have to find that one, right?
Yeah.
Okay. Basically, it should be 5 because that's the right angle triangle.
Yeah.
Because this angle is right angle. So 3, 4, and 3. We use Pythagoras.
Yeah.
Just 5, right?
Yep.
So the magnitude is 5. Actually, they should have the same magnitude, but different direction for both A and B. You don't have to recalculate the magnitude for B because they should be the same value.
Yeah.
Because both 3 and 4.
Okay.
Let's still find the angle here. So we're trying to find the angle, this angle here.
Yep.
Okay. So 10 feet should equal 3 and 4.
Yep.
Then feet should equal 10 minus 1, 3 and 4. and just calculate.
Yep.
It's 0.75, 10 minus 1.
So like, should we do degrees, minutes, seconds for this?
Yeah, that's fine.
36 degrees, 51 minutes. 52 minutes, sorry.
36 degrees, 2 minutes.
And 52 minutes.
32 minutes. Okay.
No, 52.
52.
Yeah.
Okay. So that's the angle theta, but probably the answer didn't ask the angle like this. We have to find the other angle.
To the horizontal?
Yeah, the angle to the horizontal. Now we should look at that should be. Oh yeah, redraw the diagram here.
Yep.
That's horizontal.
Yep.
A1 is 45 degrees. Yeah.
Yeah.
And that angle is 36.52.
Yep. And then we just
add them together.
Yeah. Oh,
This angle is the external angle. Just add them together, which is let's say 81 degrees 52 seconds.
Yep. So you just like could do 180 minus those two, then do 180 minus that value that you got from the triangle.
Yeah.
Yeah. Okay.
I think the answer is like they give a true bearing. It's true bearing, the answer.
Yeah, maybe.
Yeah.
So that would be like, what is it? 270 plus 81 degrees and 52 minutes.
The answer is 278.13 degrees.
Yeah. Okay. So why does it want us to do it in true bearings?
I don't know, but and also we don't know the real diagram. We just guess, but the magnitude must be 5.
Yeah. Okay. That's all good.
Yeah, but when you see the diagram, I believe you can do it yourself.
Okay.
Yeah, not hard.
Try to get a different sheet.
Yeah, sure.
So, I was trying to think what I need some help with. I guess we'll just do some more physics then.
Okay. Can you also send me your question sheet?
Yeah. I'm just downloading it right now.
Okay. And next time you just prepare all the question sheet. Send it to me before a session.
Yeah, before.
Yeah.
Yeah.
Not too bad. Oh yeah, got it. Okay, which question?
So I want to do the hardest one.
Which one do you think is the hardest one?
I'm not sure. Like, we try 5.
5? Okay, let's do 5. Strong terms used in the coefficient. Okay, I just copy the diagram here.
What does adhere mean?
Adhere means stick, just like stand still.
Oh,
Yeah.
okay.
Okay, so still the balance, the force balance. This object here. So one day, when the snow adhere, there means the force is balanced and no acceleration. So
Yeah.
this force, the red one, the red line represents the friction, right?
Yep.
So we have to use the maximum friction.
Yep.
Yep. And then, so what's the pressure for the snow have on the slope? The pressure? Pressure means this direction, right?
Yep.
Pressure caused related to caused by gravitation, right?
Yeah.
Yeah. Okay. So that's a triangle here. So this is feet. That one should be feet as well, right?
Yep.
Then the pressure here, and the pressure should equal this force here, the normal force.
Yep.
So N should equal mg cos feet, right?
Yep.
So that's this one, same thing. That's pressure.
Yep.
And the friction. For this one's friction, what friction equals? The friction should equal, look, mg, the maximum friction should equal, alright, I don't write mg, right, n times the friction rate, 0.46, right?
Yep.
So that equals 0.46 mg cos feet, right?
Yep.
So that's the maximum friction.
Mm-hmm. Yep.
And there's force to this way, right? If there's no friction, of course the snow won't adhere there. They should just go down, right?
Yep.
So yeah. So what's the force and in this the force caused by gravitation? I mean, this direction. The force.
Yeah. Oh.
That one, right? Is it?
Yeah.
This force is mg sine feet, right?
Yeah.
So make it equal each other because friction should overcome this force to make it balance.
Yeah.
So mg sine feet should equal 0.46 mg
Yeah, that makes
cos feet, right? So mg cancel out, and you find sine theta equals 0.46 cos theta. So sine theta over cos theta equals 0.46. That means tan theta. So tan theta equals 0.46. Then theta equals tan minus 1, 0.46 should be the answer.
Yeah. Should we get the angle then?
Yep.
So that's degrees.
Yep, that's fine.
So 24 degrees and 42 minutes.
Okay, 24 degrees.